Hello everyone, this is the Earth Archives. There was an abnormal eruption in Yellowstone Park in the United States a while ago, which made people think of the possibility of a Yellowstone volcanic eruption. Today we will review the 3 eruptions in Yellowstone Park and how big the impact would be if it erupted today. Before the show starts, please help subscribe, like and turn on the little bell. This will help the Earth Archives grow. The show starts. Yellowstone National Park, a jewel of the United States, is renowned for its breathtaking landscapes, geothermal wonders, and diverse wildlife. However, beneath this serene surface lies a formidable geological force, the Yellowstone supervolcano. This supervolcano, capable of producing eruptions of cataclysmic proportions, has erupted 3 times in the past 2.1 million years. Each eruption has left an indelible mark on Earth's geological and ecological history. This article delves into the scale and impact of these 3 monumental eruptions, exploring the evidence, consequences, and potential future threats posed by Yellowstone. Through a detailed and rigorous examination, we aim to present an easy-to-read yet comprehensive account of one of Earth's most powerful natural phenomena. Understanding supervolcanoes. Definition and characteristics. Supervolcanoes are defined by their ability to produce eruptions that exceed 1,000 cubic kilometers of volcanic material. Unlike typical volcanoes, supervolcanoes do not have the classic conical shape. Instead, they are characterized by massive calderas formed after the ground collapses into an emptied magma chamber following an eruption. Formation and structure. The formation of supervolcanoes involves the accumulation of a large magma chamber beneath the Earth's crust. This magma chamber builds up pressure over time, leading to an eventual explosive release of magma, ash, and gases. The resulting caldera can span tens of kilometers in diameter. The geological evolution of Yellowstone. The Yellowstone Hotspot. The Yellowstone Hotspot, a mantle plume located beneath the North American plate, is responsible for the region's volcanic activity. As the tectonic plate moves over the stationary hotspot, the heat and magma from the plume create a series of volcanic features. The 3 major eruptions. Yellowstone has experienced 3 super eruptions: the Huckleberry Ridge eruption, 2.1 million years ago, the Mesa Falls eruption, 1.3 million years ago, and the Lava Creek eruption, 640,000 years ago. Each of these eruptions has significantly altered the landscape and climate of the region and beyond. The Huckleberry Ridge eruption. Scale and magnitude. The Huckleberry Ridge eruption is the largest of Yellowstone's 3 eruptions, releasing approximately 2,450 cubic kilometers of volcanic material. This eruption created the Huckleberry Ridge Tuff, a vast deposit of volcanic ash and rock fragments. Geological evidence. Evidence of the Huckleberry Ridge eruption can be found in the widespread ash deposits across North America. These deposits provide insights into the eruption's magnitude and the distribution of volcanic material. Environmental and climatic impact. The eruption had profound environmental and climatic impacts, including a volcanic winter that significantly lowered global temperatures. The vast amounts of ash and sulfur dioxide released into the atmosphere would have blocked sunlight, leading to a cooling effect and disruption of ecosystems. The Mesa Falls eruption. Scale and magnitude. The Mesa Falls eruption, while smaller than the Huckleberry Ridge event, still released an estimated 280 cubic kilometers of volcanic material. This eruption produced the Mesa Falls Tuff, a layer of volcanic ash and debris. Geological evidence. Geological evidence of the Mesa Falls eruption includes ash deposits found across the western United States. These deposits help scientists reconstruct the eruption scale and the flow patterns of the volcanic material. Environmental and climatic impact. Similar to the Huckleberry Ridge eruption, the Mesa Falls event would have caused significant climatic changes. The release of volcanic gases and ash would have led to cooling temperatures and disruptions in weather patterns, affecting plant and animal life. The Lava Creek eruption. Scale and magnitude. The Lava Creek eruption, the most recent of Yellowstone's super eruptions, released approximately 1,000 cubic kilometers of volcanic material. This eruption formed the Lava Creek Tuff and created the current Yellowstone caldera. Geological evidence. Ash deposits from the Lava Creek eruption are found as far away as the Gulf of Mexico. These widespread deposits provide crucial data for understanding the eruption's magnitude and the dispersal of volcanic material. Environmental and climatic impact. The Lava Creek eruption had significant environmental and climatic effects, including a volcanic winter that impacted global temperatures. The eruption also caused massive destruction to the surrounding landscape, reshaping the region's topography. Predicting the scale of a future eruption. Potential magnitude. A future Yellowstone eruption could range from a VEI 7 to VEI 8 event. A VEI 8 eruption would be catastrophic, releasing over 1,000 cubic kilometers of material and causing global climatic disruptions. Immediate impact of an eruption. Ashfall. A super-eruption would produce vast quantities of volcanic ash, spreading across thousands of square kilometers. Ashfall would disrupt transportation, damage infrastructure, and pose health risks. Pyroclastic flows and lava flows. Pyroclastic flows, consisting of hot gas and volcanic matter, would devastate the surrounding area. Lava flows, while less explosive, could cover large regions with molten rock. Volcanic gases and atmospheric changes. The eruption would release sulfur dioxide and other gases into the atmosphere, forming sulfate aerosols. These aerosols would reflect sunlight, causing a significant drop in global temperatures, a phenomenon known as volcanic winter. Long-term environmental and climatic effects. Volcanic winter. The injection of sulfate aerosols into the stratosphere would block sunlight, leading to global cooling. This volcanic winter could last for years, disrupting weather patterns and agricultural production. Impact on ecosystems. The environmental upheaval would have severe consequences for ecosystems. Ashfall, pyroclastic flows and climate changes would devastate habitats, leading to species extinctions and biodiversity loss. Water supply and quality. Ashfall and pyroclastic flows would contaminate water supplies, making them unsafe for consumption and agriculture. Changes in precipitation patterns could also affect water availability. Societal and economic implications. Human health. Immediate health impacts include respiratory issues from ash inhalation and injuries from pyroclastic flows. Long-term effects could arise from contaminated water and food supplies. Economic disruptions. The economic impact would be profound, affecting agriculture, aviation, and infrastructure. Recovery and rebuilding costs would be immense, and global trade could be disrupted for years. The Yellowstone supervolcano represents one of the most significant natural hazards on Earth. Understanding its potential for future eruptions and the wide-ranging impacts on our environment, climate, and society is essential. Through detailed scientific research, monitoring, and preparedness efforts, we can better anticipate and mitigate the effects of this powerful natural force.